Well, thanks again, everybody, for joining. I'm glad to see that we've got so many participants that have not used temporal tables, so this should be interesting. Let's get started. So yeah, the title of today's talk is Using Temporal Tables for Data Forensics and Auditing. My name is Baca. I am a BI consultant with Pragmatic Works. I've spent much of my career working in various aspects of data warehousing and business intelligence. And I'm online, so if you guys have questions for me, want to reach out, comment, there's some of my contact info there. So briefly, what are we going to talk about today? We're going to start with the basics. What are temporal tables and why would we want to use them? We'll talk about some use cases about using them. And then much of what we're going to do today is going to be focused on demos around how do we set up temporal tables, configure them, how do we use them. We'll have some demos of how to query a temporal table, and that's where we get into the data forensics and the auditing. And then we'll talk a little bit about, once we have temporal tables set up, how do we manage them and how do we deal with the log of data that we have backed up there. So that's our quick agenda. So with the basics, what are temporal tables? So let's just get this out of the way. They are not temp tables. This is a new word. I prefer to call them system version tables. That's another word that Microsoft uses for them. And the reason I like that term is because it clarifies one key piece of functionality, and it is that they are versioned based on when the system versioned them. We'll show some examples of what I mean here specifically, but when we are versioning data, we are not keeping track of versions based on any type of business date. This is a version that's managed by the system itself. And so calling them system version tables helps me understand exactly what they are and what they are not. A system version table will automatically track history of any data changes made in your table. And we will talk a lot about how that works. A key part of how it works, though, is that each row in a table has an effective start and end date, and so that's how we can manage some of the version of different data items. Temporal tables are not a new concept. They are part of the ANSI SQL 2011 standard, and so there are other implementations of temporal tables in other database platforms. They are new to SQL Server in 2016, and they are available in Azure SQL Database. So how do temporal tables work? In a lot of ways, depending upon how you look at it, they are just a regular table. But when you get into it, what it really is two separate tables. You have your what we call the temporal table, or what I call the actual or the current data, and this table is created just like any other table. There's nothing, or using it, there's nothing particularly interesting about it. But where it gets interesting is that when you create a temporal table, it actually creates a second table called a history table. And when you do an insert into a temporal table, your insert gets loaded into your actual table or your current data. But as soon as you do an update on a record here, it will make an entry in the history table indicating the change that was made and the time that change was made. Likewise with the delete, if you delete a record from this table, that record will be removed from this table, but an entry is made in the history table indicating that that row from your current data is no longer available or effective. Where they get really interesting then is once you have data in your current table or in your history table is querying them. And there is a new sub-clause in the from statement, and we're going to have a lot of demos of this, but it's this for system time. And this clause here is what's going to allow us to do some of the auditing, forensics, and time travel. So we'll talk exactly about what that is and is not shortly. But the idea with this then is that with a single query, it will pull data from your current table and from your history table depending upon the conditions that you're querying. And we're going to have a lot of examples of that in the demos, but I do want to point out that when you're querying temporal tables, generally you're pulling data from two different tables. So why would we use temporal tables? I think that the best example of why we would use them is just tracking changes in data. We want to understand how often certain data records are updated. We want to know what fields are being updated, you know, when they're being updated. There's certain days of the week, times of the day. With temporal tables, we also have additional querying functionality, like I mentioned. So it allows us some different types of analysis. I can very quickly go back in time and say, okay, well, I see what the table looks like today, but what did it look like a month ago? What did it look like a year ago? And using temporal tables allows us to do that. We can also use them for data warehouse scenarios. So anybody who's worked with type 2 slowly changing dimensions, for example, knows the value of keeping track of history in a data warehouse. Oftentimes, however, though, when you're running your data warehouse load, your ETL process, and you're capturing dimension data, you're only capturing the data that it looked at the time of your extract process. But if your data is changing more frequently than your extract process is running, you could be missing a lot of historical changes. So using a temporal table would allow you to capture all of those intermediate changes and load those into your data warehouse. They're also pretty handy even in just debugging an application. So we'll show you in the demos that enabling temporal tables on temporal functionality on existing tables is pretty simple to do. So if there are situations where you're seeing some strange activity in your application, you don't understand why certain values are changing or being removed, you can enable the temporal functionality and do some auditing. Now the last one there I put, you know, I really wouldn't justify using temporal tables for this reason entirely, but mistakes do happen. And so if somebody, you know, wrote that update statement without the where clause on it and did a big mass update, well, that change is recorded in that temporal table. So you could go back in that temporal table, look at what the data looked like prior to the mistaken update, and do a kind of a manual rollback, if you will. So if you've ever used the change data capture functionality in SQL Server, you might have been asking yourself while I was talking, how are temporal tables different than change data capture? And in summary, they do a lot of the same, or they provide a lot of the same benefits as far as tracking history. One thing that temporal tables provide that change data capture does not is that notion of the time travel query, so that additional from clause is not available with change data capture. And then just the way that they work is quite a lot different. Change data capture relies on the transaction logs. It requires a SQL agent job to query those logs and then load into a table. And while this normally doesn't take very long to run, it is making changes in a table and having them reflected in your change data capture is the asynchronous process. Whereas temporal tables, any changes that you make to your data are immediately available in the history table. Change data capture, if you've ever used it, you know that it creates a lot of additional database objects just to support the query functionality, which in my opinion makes it harder to query. And one nice thing about change data capture, though, that the system version tables does not do is that change data capture will tell you what changed. And with the system version tables, which I'll show you in a demo, you kind of have to do a little bit of investigation yourself to compare two versions of a record to see exactly what changed. So SQL Server has another feature called change tracking. And so the difference between change tracking and change data capture and system version tables is that the change tracking will only tell you whether or not a row has changed. and it'll tell you if it was changed via an insert or an update or a delete, but it won't tell you anything about what the data looked like before and after that change. So just wanted to put these out there just for kind of completeness of the picture and trying to understand where system version tables fit into the SQL ecosystem. So that will be among my last slides. Let's switch over to Management Studio and start playing with these. So to create a temporal table, I can do this through Management Studio. I'm going to be working today in this database I created called System Version Tables. If I right-click my Tables folder and if I say New Temporal Table, System Version Table, and I select that, what it's doing is just spitting out a script template. So there's no real UI for defining these yet. So, but I do want to show that you can do that, but you'll end up with something that looks like this, which you'll be modifying. So to create a temporal table, to begin, it looks like creating a regular table, which in many ways it is. So I'm going to create a table called employee with a couple of fields, first name, last name, and we're going to play around with some vacation days as a value. But right in here is where we start defining the characteristics of a temporal table. A temporal table requires two fields, which I'm calling here my sys start time and sys end time. They must be of the date time to data type. And then this is really important here too. This clause here, I have to define them as a row start and a row end. So again, I've got sys start time, date time to. I said it's generated always as row start. Sys end time is my row end. This is my personal style. I prefer to explicitly label fields as nullable or not nullable. These by default will always be not null. So if I tried to create this table with these as row start and made them nullable, the create table statement would fail. The other thing that's really important here is this condition here, is I'm defining a period for system time. And this is an effective date period. And so to do that, I'm specifying that this is the start time of my period and this is the end time of my period. So when we execute this, we'll see how this works. Putting a primary key in the table. Primary keys are required for creating the temporal tables, and we'll see why shortly. So I can actually create this table up to this point, and this will work. It'll create me a table called employee. It'll have a field for the start time, a field for the end time. They're automatically loaded when I insert data. But what I want to do is include this to say system versioning is on. And this is what enables the use of the second table, the history table. So I am specifying the name of my table here. I want the name of my history table to be called employee_history. If I do not specify a history table, it will create one for you automatically. Well, it's going to create this one automatically anyway, but it'll name it automatically for you, and it includes, I think, like the object ID in the name. So I just prefer to name this how I want. So with that, let's just execute this and see what this looks like. Okay, so that finished, and I'm just going to refresh my browser here. And I have employee as a system version table. So you notice that system version tables are, if I can zoom in here, oops, I don't have that, yep. System version tables have the little clock there next to it, so indicating that there's some notion of time being used. And then of course this label of being system versioned. If I expand this, this will show me the history table that I defined in my create statement. And I can expand this and look at it that way. So this table here, this history table, does not appear as a separate table in the list of tables here in Management Studio, but really it is more or less just a regular table. So I want to point out, this is something I did not demonstrate. I created this table on the fly, and it by default created this table with the same structure as my base table or the current data table. So I have the same fields. It's created without any constraints, which is by rule. You can't have any constraints in your history table. But if I wanted to, I could have created a table ahead of time called employee history and defined it. So if I had a certain indexing strategy that I wanted to use, I could define this table ahead of time and then just reference it here in this create statement. But the way that I did this, though, if you don't have the table and you specify the name of it, it will create that table for you. So now that we have a temporal table, I'm going to load some sample data in here. These are just some names of some people, some hire dates, a little bit about their vacation time. And let's just inspect this data in here. So you'll notice that I specified values for first name, last name, and these vacation fields. But these two fields here at the end, my sys start time and sys time, are populated automatically. It's important to know that the system times are in UTC. So if you're ever doing any querying on your data, you'll have to remember that we are looking at UTC. So this is the time that my row is inserted, and then by default, any new record that's inserted uses the maximum upper limit of the date time 2 data type as the end time. So what this is telling me right here is that each of these rows is effective as of January 10th, and they expire essentially, out here in 99.99. My history table at this point, of course, is empty. But I just wanted to point that out. When you do your inserts into a table, that does not impact the history table. So let's modify some of the data in here and see what happens to my history. So I'm just picking on employee 1, my Ann Baker, and I'm just going to change Ann's vacation balance with a quick update here. And then let's go and inspect our table now. So Ann's vacation balance was previously 5 days. I increased it to 6. And you'll notice, I know this is a little bit hard to see here, but the start date, the effective date, is new. It's now later because it's a new entry in the table there. And now if I query my history table, I'll see an entry in here for the original amount of vacation that Ann Baker had, and you can see that that record is tagged then with an end time. And that happened all automatically. And I'm going to do this again actually. I'm going to show the execution plan on this, and we're just going to update another one and kind of show you what's happening behind the scenes when we run these. So I'm just going to change Ann's vacation balance again from 6 to 7, and we'll take a quick look at the execution plan. So there's really two big things happening here. Number one is that we're updating the employee table here. That's the current data table. So that's where the change from 6 to 7 happens. And then we're inserting into the history table. So that's the second operation inside this execution plan. So you can see that all in one query, it's taking care of updating the current table, and it's creating an entry in the history table. If I were to delete a record from my current table, let's take a look at that execution plan and see what's happening. So it's removed the record, deleted the record from the current table, but it has made an entry in the history table. So let's see what that looks like. So on the top I have my current data, and on the bottom I have my history. So we see here that I do not have an entry any longer in the current table for employee 3, Emma. Emma was deleted, and that record was tagged with an end date. And then you can see the history of changes that we made for Anne on her vacation time. So up here again is the current data, effective as of this time, and then here are the historical data with their start and end times. So that's how we set up system versioning tables. Let's get into a couple things that I think are pretty interesting. With SQL 2016 and Azure SQL Database, there is some new metadata available to help us find and learn about the temporal tables that we have in our system. So in sys tables, we do have 3 new fields. So if I execute this, sys tables will now tell me what type of temporal use a table has. So in my database right now I have really just the one table with the history table. So this table is still just a table, like we know, it's just a user table, but it has this temporal type. So this employee, which is my current, is called a system version temporal table, but you can see that it has a related history table ID. And I can see that here that employee history is a history table that does not have its own history table. I'm going to switch over and run the same query on the worldwide import, or I'm sorry, wide world importers. This is the new sample database available from Microsoft. We'll just run this here with a little bit more information. So in that sample database, they've implemented temporal tables pretty widely. So a lot of these, you can see buying groups, for example. There's a buying groups in an archive and the different table types there. But down here, customer transactions is not a temporal table, and that's just indicated with this 0 and this label of non-temporal table. We also have an additional object property that's available to us. So if you've ever used the object property function, it has a new argument we can pass in and have it tell us the temporal type of a given table. So if I run that query here, and I just picked a couple sample tables from wide world importers, I can see that sales invoice lines is of type 0, which is non-temporal. Sales customers has a type of 2, which we saw from above is a temporal table, and then the archive table in this case is a 1, which means that that is a history table. There's also a new table, metadata table available to us called sys.periods, and this is just a list of all temporal tables in a database and their start time and end time columns. So this is the object ID of the table and the ID of the column. So, you know, with a little bit of SQL, you can write something that might show you the name of the table and the name of the start and end columns. So this is just joining on sys columns and telling me the name of, okay, so this table called buying groups, these are the start and end dates for the temporal functionality. Let's get into querying this. So I mentioned before about the time travel and the auditing. In the from clause, we now have 5 new sub-clauses available for use with temporal querying. And they all start with this key of for system time, and that's going to indicate to the query that we want to do a temporal query. So I'm on the wide world importers database here, where we've got, I know that there's some history of the data in here. If I run this query against sales customers and I don't use any of these sub-clauses here, this is just a regular query. This is going to run against only the current table. It's not aware, or it's not using the history table. So this will tell me for these 4 customers that I've identified what the data looks like today. Now this is where this gets a little bit more fun. If I add this clause here, for system time as of, this is going to query the current table and the history table and return me a data set of what these 4 customers looked like as of this date. So remember, this is UTC. I just want to point this out at this point, but I'm just using dates at this point, not getting into time just for simplicity of the demo, but just want to remind you that that's a UTC. And so this query pulls back 4 records, 1 for each customer. But we can see that as of 2015, January 1, these 2 records have actually expired since then. But as of January 1 of 2015, these were the credit limits for Anna and Aline. Right? So Anna had a credit limit of $18.90 and Aline had a credit limit of $36.75. If I change this, for example, and let's just go out to 2017 more recently, which is, I guess, what I was showing before, more or less, we can see that, okay, in this case, I haven't changed any data since the beginning of 2017, but we can see now what Anna and Aline's credit limit look like today. And so that was just by changing the value in my query here in this system time as of. And this is what's known as the time travel query. It's really just that. I can just put a different point in time here and run my query again, and it's going to go back and tell me what the data look like for these 4 customers at this point in time. Oops. So the next 2 that I have here are for system time between. So I can give it 2 dates where I'd say I want to query this data, any changes that were effective, or I'm sorry, any records that were effective between 2 dates. The other one that I'm just going to talk about at the same time here is called system time from, and this one includes 2 dates as well. The only difference between the system time between and the system time from is how the upper limit of that query is treated. On the between, it does an inclusive, so basically a less than or equal operator, whereas the from is not inclusive. It does a less than on the upper limit, and that's the only difference between those 2. So let's run, and so I don't have a great example showing the difference between those 2 because it kind of gets into splitting hairs with the equality and everything. But so a couple things happen here. We can see that with this query, a couple of my customers that I was using as samples are appearing twice. And so that means that between the dates of 2013, January 1, and January 1 of 2014, for Daniel, for example, he had 2 different records that were effective during this time period. So he had one that was effective from January 1st, but expired on July 1st, and on July 1st he had a new record that was effective, and then that one, for the purpose of this query, this date doesn't matter, but the point is that these 2 date ranges fall between the 2 dates that I used in my query here. And this is where we can get into some of the auditing, where if you want to ask questions like, well, tell me, which items had changed at all between these 2 dates, this is where we can start getting into some of that analysis. So similar query, just for demonstration purposes, I'll run this, but we should see, I believe, the same results. So again, Daniel and Olia are coming back twice because those effective dates fall within the date range that I used in the query. The next one here, this for system time contained in, this is going to show me any records that became effective and expired in between these 2 dates here. So I can see from just looking at this record here for Daniel, for example, this record became effective within 2013, but it became ineffective, or it expired outside of the range of my query. So I would not expect this row here to come back in my query. And so with this condition here, I only have a couple matches. And so just by looking at our data here, we can see that Daniel, this particular record with his credit limit of 2,900, this version of the record was effective from January 1, 2013 through July 1 of 2013. And those two dates fall in between this range of 2013 January 1 and January 1 of 2014. So this is just another way, if you're interested in that type of analysis where you want to know which changes were entirely contained within two dates, this is the clause that you would do that with. Now when I'm using these, more often than not, what I'm using is this clause here that says for system time all. And so what this will do is it will return all history from your table. So I'm, for the demonstration, just focusing on 4 customers in my example. So this query will return all history for those 4 customers. And so we can see that each of these, in this case, have had 3 different versions. Now, you'll notice here for Daniel, the one with the end date of 99.99 is the one that's current. But this query will also pull back all of the history associated with it. So this to me is the simplest case of auditing where somebody might say, hey, for a given entity, show me all of the changes that have happened that we have history of, and that's just done here with for system time all. So I'll run through a couple more examples. I do want to show the execution plans work better in this one, so I want to show you what that looks like when we do this. So I'm going to do a quick query here saying system time as of a certain date. So this is that time travel query where I want to say, show me what these look like on this particular point in time. And looking at the execution plan, remember I was saying before that when you're querying and you use the for system time clause, you're combining data from your history table and from your current table. And this is a really simple illustration of how that works. So I'm only querying my table called cities in the application schema, but what it's doing underneath is pulling data back from the cities archive, which we can see there. Whoops. So it's pulling from the cities archive table, and then it's pulling from the cities table, and then it does this concatenation operation, and that's where it figures out, okay, I see some history in the history table, but I also see some current data in the current table, and this operation here will figure out which of those was current as of, and I erased part of my query, but it will figure out which one of those was current as of this particular point in time. And in here you can see, if you want to look at some of the query clauses, you can see the less than or equal there and the greater in here as well. So these are kind of neat to play with when you start querying your data. So if I wanted a query that joined 2 tables, each of which were temporal tables, I can do that. There are a couple tricks here. If you're using the temporal queries, this clause of for system time has to appear after the table name. So it's from table name for system time, and then if you want to alias, you put the alias at the end of it. Now, each of these tables, my customers and cities, are both temporal tables. I could say something like this, that I only want to query customers for a certain point in time, but the cities, if I don't specify anything, it's going to pull just the current values for my cities, and that would look something like this. And so that works. So what's happening here is that the information about the customer which is my credit limit, is the credit limit as of this date that I specified, but the population that I'm pulling from the city, the way that I have this written, is the current or most recent population. If I put this back though, now it's going to query these. In this case, I'm using the same date. I want to know the customer's credit limit as of a certain date and the population of the city that they lived in at that same point in time. And so our population numbers here did change between the two queries. So that's just a quick illustration of how you can query multiple temporal tables at once. Now I could do this. I could say, tell me what their credit limit was January 1st of 2015, but show me the city population as of this date. I can use different dates here if I want. And so in this example, this population here is the population as of this date. The credit limit is as of that date. So if you had a query with a lot of tables, that could be a lot of work. I mean, I think more often than not, you would probably want to do something like this where the dates are the same. So one thing that's really neat with temporal tables is that if you create a view using temporal tables, which I'm going to do here, so we know that my customers and cities tables are both temporal tables. I'm going to create a view that joins them together. Ah, good, there's already a view there. Now when I'm querying my view, I can say for system time as of a certain date, and this clause here will apply to all tables in the view that are temporal tables. And so I can run this, and what's happening under the covers then again is that this view, remember, it's pulling data from two temporal tables, and so this for system time as of clause is being applied to both of those, and that just happens automatically if those tables are joined in a view. So we showed an example of creating a brand new temporal table, but what if you have an existing table and you want to start tracking history on it? Well,
Hey Bob, can you hear me? If so, we cannot hear you anymore. Bob? Sorry guys, hold on just a minute.
can you hear me now?
I can hear you.
Okay. I realize I just accidentally hit my mute button. How far or how much did you miss?
Just like 30 seconds to a minute, not much.
Okay. I'm going to start here then. What I was saying here was that we've done a demonstration of creating a brand new temporal table, but what I want to show now is how you can add temporal functionality to an existing table. So to do that, we're going to alter our table, and I've just selected a table here from the Wide World importers that does not currently have temporal functionality. So I have to do a couple things. I'm going to add system start time. This I just named this as start time. I'm using the date time to data type. I'm generating always as row start. And I have to provide a default value here. So this is going to be kind of tricky. It's up to you how you want to set your default value. You can either set it really far back in time, understanding that, okay, everything was effective from the beginning of time, or you can set it to something more current, just kind of to indicate that, okay, we only started tracking our history at this point in time. And this default really, well, yeah, it's going to be added when we add the column. It's going to backfill it with this value, so it's something to be aware of if you're adding table or fields to an existing table. Certainly, if the table is large, that's what was called a size of data operation. So if you're not using Enterprise Edition, that could take some time. I'm adding the end time, again, date time, generated always row end. Here I must supply the default value of that maximum date time to end date. This is required. And then I'm defining my period for system time, and I'm saying that this is my start and my end time. I'm not using this clause here, but I can make these two fields hidden. This is particularly useful just to kind of insulate this change from any applications that are reading these tables. So if you've got applications that are doing select stars reading from here, if you do a select star and these fields are created as hidden, they will not appear in your query results. For what I'm doing, I like seeing those, so I'm going to add those in. So I'm going to alter my table, add the fields, and that's that. So we're almost done with that. The next thing I have to do after I have those fields available is I have to turn system versioning on, and I'm going to specify where I want my history to go. In this case, I'm telling it the name of the table. I have not defined what this table looks like. It will create that for me, and it did that. So now I'm just going to do a quick query of my table again for my selected transaction, and you can see it's added the fields for start time and end time. So let's go ahead and update the quantity here. Instead of -10, let's just make it +100. Okay, and so now let's just do a complete audit of that transaction for system time all. So we can see now that I've added the fields, the start time, end time for the temporal functionality, and it's now keeping track of history. So doing the reverse, if you no longer want to track history, if you're done using it, or you've got too much data, or you've identified that bug and you don't need it anymore, you just have to do a couple things. The most basic thing here is just you just set system versioning off. So if I do that, that will stop the tracking of history into the history table. So if I updated that record again, it would still obviously update the record. It just would not make an entry in the history table. And if I wanted to completely undo everything I just did there, I drop my default constraints on the timetables, and I can drop those two columns. And if I want, then I can also blow away my history table. I'll leave that there for now. But that's a quick demonstration of how you can enable temporal functionality on an existing table. If you have an existing temporal table but you need to add fields, for example, there's really not much to that. You can do that pretty quickly. So my cities table here is already a temporal table. I've got, whoops, and I've got my new field in there already. We're going to add a new one called new field 2. So this syntax is exactly the same for a temporal table as it is for a non-temporal table. But what we'll see here now is that in both my current table and my archive table, I've got a new field in there. So with the single alter statement, it added my new field to two separate tables, both my current and my history table. And then likewise, if I want to drop that field from a temporal table, it will do that. So there's really not much change syntactically going on there. So I think the last demo I want to show is, I'm going to go back to my demonstration here of how do we manage the data that's in the table. So after a while, maybe you've got a lot of history data and it's just taking up space and you're not looking at it anymore and you just don't need it anymore, but you still want to track history. We can remove data from your history table. What I want to show you right here is just an example of what will happen if you try to do this. So I don't have an employee 999, which is why I kind of did this. But if I try to run a delete statement on my history table, I'll get this message saying that you cannot do it. So if I really want to manage that history, the first thing I have to do is to disable the history tracking. So I'll do that with an alter table, turning the system versioning off. And now, even though I don't have any data for this, this delete query will work. It certainly didn't remove anything. But now I can write something like this, for example. If I say, okay, well, I want to get rid of any data that, that expired a year ago, right? I could do something like this. Now I don't have any because I created the table 20 minutes ago, right? But we can see where we're going with this. If I wanted to delete history for a certain employee, maybe somebody has left or there's some entity that's no longer needed. Oops, I must have deleted them, or I didn't make any changes. We can just do this. There we go. So now I've removed my history entirely. So after I'm done managing that, and I've kind of cleaned up my data, I want to make sure that I turn my versioning back on. This is a mistake I had made in the past. If I'm re-enabling system versioning, I have to explicitly tell it which table again. Right now, the table in the current state, it's just two separate tables. Employee is not a temporal table at this point, so it really has no relationship between, or no relationship to the employee history table, I should say. So just by setting the versioning on, if I don't specify this table, it will create a default table for me. But in this case, I want to reuse that table that I have. And now my table is back to being a temporal table. But as we know, I've removed all the history data from there. That was it for the demonstration. A couple other quick notes about temporal tables. Some of these I've touched on. Temporal tables must have a primary key, which might seem obvious, but sometimes tables are created without them. But the primary key is what links the current table to your historical table. Your history table cannot be in a different database, so if you're thinking of a strategy of managing history in a different database from the current data, that will not work. The history table, you can create indexes. In fact, that's a recommendation. I mean, you can specifically create indexes to fit your needs, but you cannot add any constraints to it. So you can't add defaults, you can't add foreign keys. That table is just a pure record of changes that were made in its parent table. You can't create index views on top of temporal tables, and the reason for that is because when you're using the time travel queries, those are non-deterministic, and a feature of an indexed view is that all of the queries on them must be deterministic and that they return the same results every time you run them. Triggers, you can use what's called an after trigger. Those work, but instead of triggers are not allowed. Using an instead of trigger runs an operation that's different than the one that was executed by an application or a query, and that just kind of it defeats the purpose in a way of using the temporal tables. Partitioning, I mentioned it there. You can use partitioning. If your parent table is partitioned and you create your child table, it does not take the partitioning with it. You would have to create that ahead of time, but you can do that. And then replication, always on works with temporal tables, but you can't do merge replication. And with transaction replication, that only works with a single subscriber. And that completes what I wanted to cover today. I hope everybody enjoyed it, learned a little bit about temporal tables. And at this point, Liz, I'm ready to take some questions.
All right. me get this. All right. The first one is, can you replicate a temporal table?
Yes. I can just answer that one just quickly there at the end, yes. There are some restrictions, but in short, it's possible, yes.
Does the temporal table, history table, HODL changes to the, I don't know what that one's saying, so we're going to move
Okay,
on.
I'll take a look at that one offline,
Yeah.
yep.
Have you used them in SCD use cases?
Only for demonstration. If you use them, the ETL process does become more complex. So you do have to change the way your ETL works because generally when you're querying your dimension changes, you're only getting one instance of a record, and so most ETL logic is built to understand how to deal with a single instance of a record. And it becomes a little bit more complicated when you are pulling multiple instances and checking whether or not a version of a row already exists in your dimension.
Okay. How many temporal tables can you create?
I mean, in the database, you can create as many really as you want. Each table in a database can only have one history table, and a history table itself cannot have another history table. So that chain ends there. So by that I mean, now that this table here in my example of employee history is a history table, I cannot add history to the history, if you will. I hope that answers that question.
Okay. Are temporal tables a replacement for CDC?
They're not a replacement for CDC. CDC, it works a little bit differently. I mean, CDC will tell you it'll tell you what changed. In all those queries that I did with the system version tables, I kind of had to inspect the data. So I was looking at populations, for example. I had to go and look to see, okay, well, what really changed on this data? And system version tables don't do that. Change data capture will. So no, it's not a replacement. I guess it's just a different technique for it.
Okay. What is the overhead and performance by using temporal tables?
Good question. So I mentioned the indexing of the history table. So there certainly is some overhead, but that overhead is limited to an insert on the history table. So as long as your the history table is indexed correctly and it can accept the inserts quickly, then you can minimize the overhead that way. But yes, there is overhead. It's doing an extra operation to load the history table. But so yeah, again, you can work out an index and partitioning if you wanted, or to help improve that overhead or reduce the overhead.
Can you have CDC and temporal tables in play on the same table at the same time?
Yes, I have not done that, but you can do change data capture on a temporal table.
Okay. Is temporal tables feature available in SQL Server 2016 Standard Edition?
Yes, yes it is. It's available in all editions of 2016. It is not an enterprise feature. I'm 99% sure of that.
Okay.
But it's not. It's first available in 2016, so it's not available in versions prior to that.
Okay. How can you query or identify deleted records?
Good question. Okay, so that would be, I guess, a combination of two things. I'm trying to look at my table here. So I did my delete. You would have to look at the history table. So in my example here, I wiped out my data, but you would have to query your history table for employee IDs in this example that don't exist in your employee table. And then the version that was the most recent in the history table would be that has the most recent end date. So yeah, it's kind of a it's not a super straightforward operation. So yeah, again, you'd have to compare what is in your history and not in your current table to understand if a row is deleted.
How long do temporal tables keep history for?
For as long as you want. Yeah, under the covers, it's really basically just another table, and so that's what I was kind of showing in my last demonstration here. Until you come in and clean this up yourself somehow, it'll keep that data just like any other table. There's no time limit. Now you can set things up to kind of automate some of this to say, okay, I'm going to run a daily process or whatever that trims it after data that's older than a certain date, but no, there's no setting to say keep it for this time.
Okay, we've had several questions along this line.
Okay.
Can you speak a bit about applying temporal tables in a data warehouse slowly changing dimension scenario?
Yeah, so to me the most valuable aspect of that is if the source of your dimensions is changing more frequently than what your ETL process currently is running. So for example, if your ETL process is running once a day, but you know that within a given day there are frequent changes to your data, it's really a good scenario for grabbing all of those changes and not just the one that was current as of the time that you ran your process. Now downstream it does become more complicated in that you have to write the logic to check to see if a version of your dimension row already exists or not. And so that logic does become a little bit more complex than what you have today. And a lot of that depends on how your data warehouse functions, as far as which fields are type 1 and which ones are type 2. So just because a row changed in your source system does not necessarily mean that triggers a corresponding change in your data warehouse, for example. So I would try to isolate the logic focusing on type 1 changes where I'm only looking at the most recent value, and those things that are type 2 changes where I do want to keep track of those, and you kind of have to have separate paths for those sets of logic. Yeah, certainly there's some benefit, but it does introduce some complexity.
Okay. Well, we are just past 12 o'clock, and there are a ton more questions. So
Okay.
I'm going to make sure that we get these to Bob, and he will do a blog for us follow-up. So stay tuned for that. As always, the session was recorded, so you will receive an email tomorrow with the link. Bob has also offered to share his materials from today's session, so I will try and include a link in that follow-up email with those. If you have any questions that you didn't get to put in the panel or that you really want us to answer, you can email me, Liz, and I'll be happy to pass those along to Bob. Again, thank you everybody for joining us. Bob, thank you for presenting today, and we will hopefully see you next week.
Thanks, everyone.
Thank you.